In this video, I'm going to show you how you can visually represent test-retest reliability using a Bland-Altman plot. So the data is the same that I used for the interclass correlation video that also looked at test-retest reliability. The two variables here represent scores on the attitude towards goat's cheese scale. Goat's cheese being the greatest culinary offence of all time. And what we have is our participants complete it at time 1 and 2 weeks later complete it at time 2. And we're interested to see how stable the scoring is on our scale. So to produce a Bland-Altman plot, we go to reliability, and we accept Bland-Altman plots there. So it's quite a straightforward procedure. We click across our two variables, and this is our Bland-Altman plot there. We can also get confidence intervals around our top and bottom line. I'm just going to add them now. So we've got our confidence intervals there. We can even shade it as well. And even add some color if we want. So let's have a look. So we've got our Bland-Altman plot. So what's this actually showing? Well, we've got our mean of measurements and then the differences between our measurements. So this is the mean of our participants' scores. So each participant's got two scores, and we've got to work out what the mean is. And then we've also got the difference between measurements here on our y-axis. And essentially what we want to see is we want our dots, our participants, or the differences between scores to be clustered around 0. So anyone smack bang on 0 means they got the same score on time 1 as they did time 2. We want people essentially to be within these two lines here. These are our limits of agreement here. Basically, these are just the mean difference plus 1.96 times the standard deviation. People who are beyond these lines, so this person here, for example, this person up here, and there's a few others dotted around a bit nearer, have very different scores between our two times. We can actually clarify what these things measure if we ask for our Bland-Altman table. So basically what this is our mean difference plus 1.96 standard deviations. So that's our upper limit is 3.533, which sits there. And we've got our lower mean difference here, which is minus 1.96 times standard deviation, which is represented here. And it's our mean difference in the middle. We have confidence intervals around that. So what we've done is just simply plot the stability of our scale. And you can see it's relatively stable. Most people do fall between our limits of agreement there. So most people, there are a few people who are a little bit out. So this person's quite a long way out. Maybe worth actually checking their data that's so far apart. But this goes quite well hand in hand with an interclass correlation as a nice visual representation of your test-retest reliability.